Today we will look at another function of the data link layer. With data link layer, we talked about error detection. Now we need to talk about another problem that faces communication with neighbors. And that is flow control. So let's first connect this correctly. Let's share. So there are a couple of things that we need to be aware of before we talk about control. Solves the problem of having the two machines, the two neighbors. One is too fast for the other, one is too slow for the other. Especially one situation where we have a fast sender and the receiver is an old machine, maybe with less memory and less processing power or speed. So if the sender starts sending data, if you're downloading a video, starts sending you lots of packets or frames, and the receiver is a little bit slow, so it starts processing a frame, but another one arrives, so it's put in memory, temporary, until we finish with this frame, and then pick the next frame. But by the time you pick the next frame, there are 3 or 4 more have arrived. And by the time you do another one, there'll be about 20 there, 20 frames, and the sender is just so fast. It gets to a point, if the sender is really fast and the receiver is really slow, is that there'll be no more space, there'll be no more memory to store any more information coming in, and we start losing data. And then it might have to be retransmitted, depending on the network. So we definitely don't want the sender to be too fast, faster than the receiver. If it's the other way around, if the receiver is really fast, so the sender sends one frame and it's landed in the receiver. So by the time the sender wants to send another frame, starts sending another frame, the receiver processes this for error detection, everything is good, send it, it's the next. So it has to wait for the next. So it's no problem, it can wait. So if the sender is slow, normally we'll have no problem. The problem, so flow control problem, if you're asked what's flow control problem, it's the problem when we have a faster sender and a slower receiver. That's when we have the flow control problem. This is known as flow control. It happens between neighbors, directly linked neighbors, if the sender is very fast and the receiver is very slow. It can also happen between end-to-end communication. One, the initiator of the communication and the final receiver. It could be on the other side, both sides, or each is on the other side of the world. But one is sending fast information, the receiver can't just cope with it. So flow control is also used between end-to-end in end-to-end communication. So how do we get a system that only slows the sender if the sender is fast and does not affect it if the sender is slow? So if the sender is fast, we want it to slow down a little bit. So they have this system that they call the flow control. And it's a sliding window protocol. It's known as the sliding window protocol. Just one moment, I need to get my sheets of paper here. And It uses something called the sliding window. And the sliding window protocol is a technique basically that will slow down the sender. And how does it slow down the sender? They do agree on one thing, they agree on something, and they call it the window size. So they agree on the window size, and the window size means what's the maximum number of frames that the sender can send before it has to stop and wait to hear from the receiver. And usually the receiver will just send something we call an acknowledgement. I mean, yeah, I got those, start sending me the next ones. So the idea with the sliding window protocol is that a sender cannot just keep sending non-stop. It has to be stopped. So we get it to stop itself by agreeing on a window size. So what does the window size? Again, it's the maximum number of frames that the sender can send until it has to stop, until it receives an acknowledgement, and then it can continue again. So there is even a shorter definition. It's the maximum of unacknowledged frames. So the window size is the maximum of unacknowledged frames that the sender can send. That means the sender can send without any acknowledgement, but when it reaches that limit, it has to stop and wait on an acknowledgement. And that's how things really work. And it's a very good system, very good protocol, very good algorithm. It works. It's been there since the start of networks and communication, and still there, and it does the job so efficiently, so nicely, with minimum of cost. So how does it work? The sender has, we'll assume the sender has a lot of data coming in. Maybe a router that receives information from other routers, and they have to go to the next router, the next neighbor. And then eventually they might go in different directions, but we have continuous supplies of packets. Or maybe the server is sending a file, a video, and sending it to the nearest router, and it's going to go wherever it's going to, a receiver somewhere. But first it has to send it to this router. So the sender is so powerful it can send lots of information forward, and we'll assume there are hundreds of frames or thousands of frames are coming, or even millions. So the sender has to say, for example, if we say window size is 5, that means sending 1, 2, 3, 4, 5, then you must stop. The sender must stop once it sends 5 frames until the receiving part can process them and say, okay, send me the next. I'm okay now, I got those 5. Send me the next 5. So it sends 6, 7, 8, 9, 10, and then it stops. So that's how the sliding window protocol. If the sender is really slow and the receiver is fast, then it will never slow the receiver. So by the time it sends number 5, this one processes and say, okay, send me the next. So it keeps sending. But if the sender is really fast and the receiver is slow, then the sender has to stop. It could maybe shoot out those 5 frames in less than a second, or maybe 5 millionths of a second or 10 millionths of a second, but this guy needs a full second to process them, so the sender has to stop. And that solves the flow control problem. So the flow control problem is solved by sliding window protocol. That's based on something very important, and that's the window size. So what's the window size again? No, what's the window size? The maximum. Don't forget the word maximum. It's not the number of frames you can send. You can send millions of frames. It's the maximum number of frames. Or you can send 2 or 5 or 3. No, what's the maximum? You don't have to send them, but that's the maximum you can send. So the window size is the maximum number of unacknowledged frames that the sender can send. Now, that's one point. Once you understand that point, the rest of it is easy. There's one other point, another concept that you need to know. In order to start sending, and then we tell you, okay, we received up to this one, send me the next group, or maybe we didn't receive them all. What happens if one of the frames is lost? What happens if you send me frame 1, 2, 3, 4, 5, but number 3, there's something wrong with it.
Oh, I guess it's still going to wait for the next one, but it just don't come because this sender maybe thing.
Yeah, but how does the sender know, hey, frame number 3 has a problem? There's a problem that some frames need to be retransmitted. So the other concept is that we must give numbers to these frames. We need to be able, the sender and the receiver need to be able to those frames. So if you send me 5 frames and number 3 has a problem, I can pinpoint, say, okay, this frame has a problem. I send it and say, okay, number 3 has a problem. Maybe you start sending number 3 again. Otherwise, if we don't number the frames, we will never know. We will not be able to talk about the same frame. But this way, we will know which frame is the problem. So they use, that's a problem, because if you have to number your frames, then we can get 10,000 frames every second. Routers are so fast that they can get maybe 10,000 frames a second. But imagine the numbers, they're going to grow so big. Where are we going to write the number? We usually write the number in the header. Remember datagram switching technique? We say, okay, if every time you want to send data, you break it into smaller units. We call them packets or datagrams. And you put the IP source address and destination address. What else do you put now? You must put the sequence number as well. So the sequence number is put in the header. But if the number, you start with 1 that, remember everything is written in binary. So you write 1, okay, it just takes 1 bit, 0 or 1. But then what about number 2? You need 2 bits, 0, 1. What about 3? 1, 1 in binary, right? What about number 5? It takes 3 bits, 1, 0, 1. That's 4, and 1, that's 5. Okay, but what about number 500? What about number 1 million? It will have so many bits. Well, what when we get to billions? So that's not really a practical way to say, all right, let's give numbers to these frames. Because very soon we're going to get frames. And if we so big just to write the frame number on. So they said, okay, let's do this. Let's recycle the numbers. Let's only pick few numbers, and you start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and maybe back to 0 again. So you keep reusing the same numbers. You don't go to unlimited numbers. So now we know exactly how big the number field should be. And they said, let's agree with those. So first, so the concepts I want you to know are what a window size is, in order to know the sliding window protocol, and that's the maximum unacknowledged frames or packets. And then in order to recycle numbers, they say, let's pick a number. And they picked number 8. And they picked number 128 and 256 and so on. Why? Because you can fit them in nicely and neatly, and they're binary numbers. And they call them modulos. And a modulo, it comes from the number 8 as well, and it's 2 to the power of whatever. So the famous ones are 8 and 128 and 512, and they're all multiples of 2s, powers of 2s. We'll just use the smaller one just to get the idea. So modulo 8, that means we have 8 numbers. That's what we will have, 8 numbers, and we recycle them. So every time I send you packets, we always start from number 0, 0 to 7. Why? In this case, you can write in binary, you can write in 3 bits, 0, 0, 0, and or 1, 1, 1. That's 7, and that's 0 in decimal numbers. So we start with number 0, number 1, 2. Every time I send you a packet, I'll number 0. 1, 2, 3, 4, 5, 6, 7. And the next number after 7 is going to be 0. And we keep using this. If we use modulo 128, that means we're going to have 128 numbers. They start from 0. What's the last number in the modulo 8?
128.
It starts from 0 to 127. That's 128 numbers. This one is from 0 to 7. This one, 512 numbers. They start from 0.
511.
Yeah, and so on. So we agree on a modulo. And now you know what a modulo is. The modulo is just a set of numbers that we will use all the time. It's good, we know how big they're going to be, and we'll always use that size for numbering frames. But you don't recycle. Don't recycle quick. Because if I send you, the window size has to be smaller than the modulo. Because imagine if our window size is 8. Well, we'll get to that later, so don't worry about that. Right, so now these are the two concepts that you need to be aware of. First, the window size, and then the modulo. The modulo is just a set of numbers that's recycled. They're used to number and identify the frames, or packets, or whatever we are using. So now, how does it work? How does flow control work? Here it is. First, let's imagine there are two machines. And one is a sender and one is a receiver. And we'll draw it this way, and you two are expected maybe to have a diagram, something like this, that shows the exchange of information or packets between the sender and the receiver. And this will be controlled by time. We'll do it over time. So we have a timeline here that has, whatever it is, millionths of seconds or whatever. It doesn't matter too much. So now every time the sender sends any frame, always we'll draw it in an arrow going in this direction. But we'll always draw it going down a little bit downward, because it starts at a certain time, it has to arrive later, like 2 seconds later or 2 millionths of a second later. Don't draw it going up. You can't send something now and it'll arrive in the past, at 2 seconds ago. No, if you send something, always have it, anytime the sender sends something, have it a little bit tilted downward. So you give the indication, that you sent it at this time, and it actually arrived at approximately this time, right? So don't do it backward. Now, so the sender and the receiver must agree on two things. One of them is called the window size. And let's pick a number, window size 4, right? Or 3 or 5 or whatever. And the other thing, they need to agree on the modulo. Modulo. What's the modulo? Let's say now we'll use modulo 8. What does it mean? It means we have all this sequence of numbers from 0 to 8, 0 to 8, 0 to 8, and we keep going along those numbers and use them as we go along. So this guy, how many frames will this guy send now? He's going to start sending. How many frames it sends and has to stop?
4.
4. Give me the numbers. You know what numbers they are?
0.
0, 1, 2, and 3. So these are frames that are being sent. Stop. The sender doesn't have to stop sending after each frame. So no, I keep sending. Why? Because the window size is 4. Once it gets to 4, it has to stop. And in fact, it doesn't get to 4. As you can see, it got to 3. 0, 1, 2, 3. So it sent 4 frames. Now, the receiver gets number 0 and checks it. The receiver knows the first frame has to be number 0. In fact, the receiver has a little variable called, what's the next frame number that I should be receiving? It's called the next frame to receive, what number it is, and keeps it. It's a variable. and every time it receives it, it increments it. So it says, the next one I expect is number 1. If it receives number 1, it says the next one I expect is number 2. And if it doesn't get number 2, then there is a problem. Okay. So now, it gets number 0, says, yeah, that's the one I'm expecting. It checks it for errors. Let's for now say, there's nothing wrong with it. It says it's perfect. What does it do with it? Imagine on your machine, you're downloading a file. It's coming to one of your programs that's a download application. Anything that comes, it has to go to one of the programs. Imagine if you're downloading music and downloading a file. There's a music application and a file downloader, document downloader. If a music packet comes in, it will go to the music app, and if it's a document, it goes to the other app. I guess you know why. How does the network system knows which app should get which packet? Do you know? How do you identify them? Do you know? Okay. Do you know which machine? If a packet, you're downloading files from the other side of the world and they're coming down. How does it know which machine? How does the computer, how does the network knows where, which machine to give this packet to?
Okay, global network can use IP addresses for that.
IP address is the one that uniquely identifies your computer. So around the world, they're looking at IP address. Oh, there it is. It's on this network. It says, there. Here's the machine. So they give it to your machine. Now, your machine, you have 3 programs. One is messaging. You're messaging somebody. A packet comes in. And one is downloading music. And one is downloading a document. Now, when it arrives, who do they give it to? Which application? There's another identifier, another address.
Port number.
Port number. Remember, same exactly like the letter you receive in the post. They go around looking for your house. Eventually, they drop the letter into your letterbox, into your house, through the door. You say the letter has arrived? No, it has not arrived yet. Who is going to open that letter? You have to open it and look at the envelope and see which name is on that. And there may be 4 people living in the house, only one of them will get the letter. So that's exactly the programs or applications that are on your computer. When any message comes in, that's identified your computer or your device by the IP address, but that's the end of IP address. Now, the network will look and say, okay, what's the port number? Because every program that wants to start downloading or sending or communicating, it will ask for a port number. It's given a port number for that session. So everything that comes in with that port number, we give it to you. Okay, so that's not part of this now, but I just wanted to make sure that everything starts making sense together. All right, so this guy is waiting for number 0. That's what it says. That's the next number I should expect. It got number 0, and it's perfect. So it will increment this number. Say, okay, the next one now I'm waiting for is number 1. Of course, while it's processing this, the others may arrive. So there's a queue here. They put these in a queue inside the memory of the network card. But this guy doesn't care about them, right? And it's perfect and there's nothing wrong with it. Then it will send it to the user. I'd put U here for user. So you send packet number 0 to the user. And remember, if you are listening to music, you want all the packets in the correct sequence. You don't want to miss, this one and get one from later one. So, or when you're downloading a file and you're writing it 1 page at a time and every page arrives in a packet, you want it in the right sequence. So it's important to keep the sequence. Now, that's fine. It finished with it. It gets the next packet, number 1. It says, oh, that's the one I'm expecting. That's perfect. Check it for errors. There's nothing wrong with it. And say, okay, increment this one. Now, the next one I'm waiting for is number 2, and this one follows to the user. So we send this one to the user. So our user will get packet number 0, number 1, number 2, and number 3. So I'll just write user. That means it's good. Let's send it to the user. And by the time you finish with number 3, now you're waiting, now you're expecting number 4. You look into the queue, there's nothing else. Remember, this thing is an event driven. The receiver checks, is there something in the queue? Yeah, take it, take it. There's nothing in the queue? Okay, I think I'm going to go sleep and wait until something comes up. And if something comes up, the operating system will wake me up. But before I go to sleep, I need to tell the sender something. I have to tell the sender, I've received those frames, 1, 2, 0, 1, 2, and 3. So I send something, we call it acknowledgement. So a small frame, only the header. It has no information in it. The acknowledgement is a tiny packet, only the header of a packet, because we are not sending information in it. No details or no, not. And in the header, there's a space for one number. Just same as the header that we received. It has a space for one sequence number. Now this guy here has a space for one number that we call acknowledgement. And what we do, we write number 4. So this is acknowledgement 4. I'm sending you acknowledgement, and you open and say number 4. What does number 4 mean? What does this acknowledgement mean? And this is what an acknowledgement means. Possibly can an acknowledgement number mean? So now, number 4, it means two things. It means all information, all packets or frames or datagrams or whatever. I write frames now. All information you sent me before this number, which is M, is okay, are okay. So all packets before 4 is okay. 4 is not okay. So when I send you an acknowledgement with number, I'm not acknowledging that number. I'm acknowledging everything before the number. Okay? Make sure you understand it. I don't say to you, acknowledgement 27. You say, oh, they have received frame number 27. No, it means we received frame 26 and 25 and 24 and so on. Okay, so the acknowledgement always acknowledges not that into the acknowledgement, acknowledges everything before it. It also means something else. I expect frame number N, this number 4 in this case, next from you. So that's what I'm expecting, waiting from you. So this number that's in the acknowledgement is the one that I'm still waiting for you to send it to me. But I'm only acknowledging everything before it, which is true, because we got 0, 1, 2, and 3 perfect, and we want to tell you we received up to number 3. So we send you acknowledgement, but we don't say 3, we say 4. Okay, the acknowledgement always indicates the one after the one that's been acknowledged. We are only acknowledging the one before it. And that number that's in the acknowledgement, is that what we have not received, or maybe received, maybe it has a problem. That's what we want from you, is number 4. So that's what we call acknowledgement, right? So the sender here would have sent all this, went to sleep, because it can't send anymore, so it goes to sleep. But it also knows it sent 0, 1, 2, and 3, and now it's waiting to send number 4, but it cannot send it until it gets this acknowledgement. When it gets this acknowledgement, it knows then all the ones that I sent you before are good. Now I'm going to send you a few more frames. What frames will the sender send now? How many frames will the sender send?
4.
We'll send 4 more frames. Can you give me the numbers they'll send? Pardon?
5, 6, 7.
4, 5, 6.
4, 5, 6.
Yeah, don't forget 4. 4, it hasn't been sent. That's the one the receiver is asking you for, number 4. So you start with number 4, 5, 6, and 7. Okay? And then it goes to sleep. The receiver, maybe it sent 4, 5, they got into the queue. And your machine here will wake the receiver and say, come on, there's something in the queue for you, something arrived. You start processing number 4. By that time, the sender has already sent 6 and 7. And nothing else can't send anymore, so it goes to sleep. So, but these 4 are actually in your machine right now. So this machine wakes up, the receiver of the data link layer, picks up the first line, the first packet, Number 4, it's okay. It's perfect. That's what we're waiting for. It will increment this number and it will send this to the user. Then 5, 6, and 7. Imagine they are all perfect. They're all sent to the user in this order, in the correct order. And we'll send back acknowledgement. So this guy received 4, 5, 6, and 7. And are you with me up there in the back near the window? Yeah? So now this guy has to send back acknowledgement. What acknowledgement number it should send? It's received 4, 5, 6, and 7. So it's, what did he say? What acknowledgement number will be sent to the receiver, to the sender, to tell them we have received up until number 7? Yeah? No, you. Yeah.
8.
Number 8. That's a good one. Everybody agrees?
Yeah.
No, you can't use number 8. We are using modulo 8. What does modulo 8 mean? Yeah, remember, modulo 8 means you have the numbers 0, 1, 2, 3, 4, 5, 6, 7, and that's it, 8 numbers. And then recycle those. The next number is 0, 1, 2, 3, 4, 5. So you're going to start sending this one here. So that's the one we expect to receive from you. The next number 0, which not the previous one. So that goes 0 there. So be careful. It's not 8 anymore. We can't send 8. 8. Why? Because to write 8 in binary, remember 0 to 7, this is 7 in binary. If you want to write 8 in binary, 1, 0, 0, 0. That's 8 and that's 7. So that means you need 4 bits. No. Only we have 3 bits in the header for that sequence number. You can't write 8. That's why in this case, if we use this modulo, the header will only have 3 bits to write the number. The maximum number you can write is 111 in 3 bits, and that's 7. After that, you go back to recycle the 0. All right? And then it just continues like that. So this guy sends the next. What frames will the sender send? Are you with us or are you? Oh, the receiver is saying to you, send me number 0. No, let me ask you another question. What does acknowledgement 0 mean? That's what acknowledgement means. Any idea? Before frame number 0 is received. See now? All you have to do is take that number that's in the acknowledgement. If I say, what's acknowledgement 0 mean? Just put 0 instead of N here. It means all frames before 0 have been received correctly. Okay, no problem. And I expect to receive from you now number 0. That's what the acknowledgement always means. Those 2 statements. Just remove the N and put that number. If I say to you, what's acknowledgement 17 means? You say, I've received everything before number 17. That's what the first statement says. All frames before 17 are received. That means up until 16 are okay. But we did not get 17. And it means also, that's what I expect to receive from you, number 17. Okay? So what does acknowledgement 0 mean? All frames before 0 are received.
And next expected one is 0.
And I expect to receive from you frame number 0. Now my next question, what frames comes before 0?
It was 4. So it means like 5.
7.
Yeah.
Number 7 comes. In this case, because we are doing modulo 8, our numbers go 1, 2, 3, 4, 5, 6, 7, 0. So the one before 7, before 0 is number 7. So it means now when you send acknowledgement 0, it means I've received number 7 and 6 and all that before the ones before 0. Okay, you need to keep this in your mind all the time. Acknowledgement with any number in it, it doesn't mean I've received that number. I've received the one before it. Right, okay, so this guy now sends, what frames will it send? Anytime you receive acknowledgement, that's the number you must start with.
0.
Yeah, see this time it's received, sent 0, 1, 2, 3 and stopped. This guy received them, sent you back acknowledgement 4. That means I got up until number 3, I'm waiting for 4. So he sent 4, 5, 6, and 7. You got them all, you send acknowledgement, what's after 7? 0. That means everything before 0 is received. Now you start with 0, 1, 2, and 3. And you keep going so that's called the sliding window protocol. How does the sender know how many frames should I send? Well, we had agreed on the window size. That's how many frames you send. What sequence numbers I can send? Okay, this is why they call this the sliding window protocol. So imagine this. Imagine we have, these are the numbers. These are the cycle. This is modulo 8, sequence of numbers. And the sender comes up and say, for example, we say, hey, we are going to use window size 4. So here's window size 4 goes, and you can now see what the sender, see the size of this window is 4. You can only see 4 numbers. And we can see, so the sender knows 0, 1, 2, 3, and he knows somehow that number 3 is the last number. It cannot send any number after that. And what will then, until the window moves, what moves the window at the sender end? This window is at the sender. Every time it receives an acknowledgement. What acknowledgement did we get when we sent 0, 1, 2, 3? We received acknowledgement 4. That means now the sender can push the window to number 4. And suddenly it shows it what are the frame numbers you can send. 4, 5, 6, and 7. Imagine if you received acknowledgement 6, for argument's sake. There's something wrong with number 6. So you receive acknowledgement 6. What does acknowledgement 6 mean? Everything before 6 is okay. So you move the leading edge of the window up to number 6. And it tells you now you can actually send 6, 7, 0, and 1. And this is why they call this the sliding window, the idea of it. The sliding window will show the sender what frame numbers it can send and where it must stop. Just based, imagine we're still using the modulo 8, but we agree on sliding window size 5, right? Window size 5. What's the window size again? What's meant by a window size? Thank you. So here's window size 5. If the sender starts at the beginning, you must put the window starting at 0. It shows you what are the frame numbers you can send. So it can send 0, 1, 2, 3, and 4. Let's say it can't send number 5. So already sent 5 frames. Imagine if it got acknowledgement, or they're all received perfect. What acknowledgement should we get back? If we agreed on window size 5 and I sent you 5 frames, 0, 1, 2, 3, 4. You've received them all perfectly. You're going to acknowledge them. What acknowledgement number you send me? Any idea? What's the acknowledgement number that the receiver should send back? If I send you, I am the sender, I send you frames 0, 1, 2, 3, 4, 5 frames. What acknowledgement would you send me back? I'm waiting now. Not hear you. 5, acknowledgement 5, that's correct. What does acknowledgement 5 mean? Oh, thank you. It's telling me, what does acknowledgement 5 mean? It means 2 things, right? Do you want me to remind you? It means I have received everything before number 5, which is correct. That means I have only sent you up number 4. So you tell me, yeah, I've received up until number 4. How do you tell me that? You send me acknowledgement 5. And it also means I'm waiting on number 5 from you. Anyway, so if you send me acknowledgement 5, I move my leading window, the start of my window, to number 5. And suddenly it shows me what numbers I can send you now. I can send you 5 more frames. They start at 5, 6, 7, 0, and 1. That's how the sliding window moves. Who moves? What moves? What causes the window to move forward? The acknowledgement that the sender receives from the receiver. So in this case here, if there's something wrong with number 6, what do you think? What acknowledgement would you send me? Okay. What acknowledgement would I get if number 6 had an error? it may, you're gonna, any idea? What acknowledgement would you send me? If I send you frames 5, 6, 7, 0, and 1. 5 is okay, but 6 is a problem. You're gonna send me back to tell me you did not get number 6. You only got.
Send a request for the packets.
It's an acknowledgement.
Yeah.
What acknowledgement number will it have?
Since the 6 has an error, so it's request for 5.
If I send you or you send me acknowledgement 5, what does it mean?
If means that the 5 is okay, has been received.
It means 5 has been received.
Yeah.
Acknowledgement 5.
Yeah. I think it's
No, acknowledgement 5. Remember, we had anytime you receive a number in the acknowledgement, it means you did not get this number. It's your acknowledgement. So if I send you acknowledgement 5, it means I've received number 4, I did not receive number 5. So that's not the case here. I said I've received number 5, perfect. It's number 6 that had the error. So what acknowledgement do you think I'd be getting or sending? 7. 7 means I did not receive number 6. 7, anytime you send acknowledgement 7, that means, hey, number 6 is okay.
Oh, 6.
But now I'm telling you, I did not get number 6 okay.
Then the sender will request for packet.
I'm just asking you what acknowledgement number. He got it right from the beginning. If I say to you, I got number 5 good, correct. Number 6 is not correct, you send me acknowledgement 6. It means number 5 is okay. Acknowledgement 6 means the one before 6 is good. I told you number 5 is good. What acknowledgement do you send me? You can only send me 6. 6, it means number 5 is good and number 6 is not good. Okay, whatever it is, I have not received it yet. Okay, so if you send me, if for example you send me acknowledgement 6, what does it mean? I'm gonna change it. Acknowledgement number 7. You sent me acknowledgement 7. What does it mean?
That everything before 7 has been received correctly.
Yeah, give me the number before 7. 6. So 6 is okay, and number 7 is not okay. All right. So anytime you receive an acknowledgement, the one before it is okay, but that number I sent you is not okay. So let's say you sent me acknowledgement 7. That means I have to move the window, but number 7 has to be there because it's not okay with the receiver. But you move the window forward, it tells you what frames you can send. This is the sliding window protocol. If our window was 3, it will show you just 3 numbers to send. You start with 0, 1, 2. If I receive 0, 1, 2 correctly, what acknowledgement would you send me? I sent you 0, 1, and 2. You got them all perfect. What acknowledgement would you send me back? 3. Acknowledgement 3. Thank you. I move then, as a sender, I move to acknowledgement 3. Says, oh, now I can send 3, 4, and 5. And I send you 3, 4, and 5. What acknowledgement did you send me back? I sent you 3, 4, and 5, and they're all perfect.
I didn't receive any 6.
6, exactly. So 6 means number 5 is okay. So I go to number 6. Now I can send you frames number 6, 7, and 0. You got them all perfect. What acknowledgement would you send me? I sent you 6, 7, and 0. You received them all perfect. What's the acknowledgement you send me? Acknowledgement 1. What does acknowledgement 1 mean? Yeah, it means number 0 is received perfectly, and I'm waiting on number 1. So I move my window to number 1. I can send you 1, 2, and 3. And that's what the sliding window protocol, how it works. All right? Now, let's look at the situation where there is an error. Let's say this guy now sent 0, 1, 2, and 3. 4 frames. It got 0, perfect. What does it do with it? What do we do with the good frame that we receive it? It's the right frame. It's we're waiting on number 0. We got number 0, and it's good. There's no error. What do you do with this frame as a receiver? What do we do with the good frame received? You're a receiving machine. Send it to the user. When you receive a good frame, send it to the application, whoever is supposed to receive it. If it's a music and you are at frame number 0, oh, who needs this? It's a music application. There you are. Let it play the music. If it's for a file, there's another application. Here you are, and they write it to the hard disk. And if you are using Messenger as well, you have 3 programs running, and there's a frame came based on the port number. Oh, this is for the Messenger application. There you are. It will display that message on the screen for you. Right? So if a good frame is received in the sliding window protocol, you just send it to the user. What do you mean good? It's in the correct sequence and there are no errors in it. Just send it to the user. Send it to the application, whichever one. We just say user now. So frame is good. And now increment the next number you want. Now we are waiting for number 1. You look at the next one, you arrive that it's number 1. It's the right number and it's good. What do I do with it? It has no errors, frame number 1, and it's correct sequence. What do I do with it? Delete it? Yeah, and no errors. You send it to the user. Every frame you receive, if it's good, no errors, the right sequence, just keep sending it to the user. I'm downloading 1,000 packets. Send them to the user. Let them, whatever it is, I'm storing them on the hard disk as a file. I'm downloading a music or a video or whatever it is. Keep passing them to the user. Unless if they're in the wrong sequence or unless they have a bit error. Our error detection found there is an error. Right. Now we got, and then pick the next frame. So they are all sitting in a queue in our memory, in the device's memory. We got frame 0, 1, we got number 2. I haven't looked at number 3, just got number 2, and number 2 has an error. We put CRC in it, and CRC checks the found, hey, there's a bit error, there's an error. So we're gonna discard it. We cannot accept a frame. Don't send that frame to your user. What do we do with it? Discard. So every frame that comes in, it's either gonna be sent to the user or discarded. There's no alternative, nothing else. And the moment you find a frame with an error, immediately shoot out an acknowledgement. What acknowledgement do you think we should put in there? This is frame number 2 has a problem. Yeah. What does acknowledgement 2 mean? It means all frames before number 2 are okay, which is correct. We got all these frames, 0, 1 are okay. And it means that's what I expect. That's what I want from you is number 2. Now, it could mean something else as well as those 2. It does not disagree with those 2 statements, but say maybe this frame number n has an error. So anytime you get an acknowledgement, it acknowledges everything before number 2 in this case. And that's what I want from you is number 2. And maybe this frame has an error. That's why I'm asking you to send it again. Okay, so it doesn't disagree with the previous statement, but it's more detailed now at this stage. If you have already received this frame and you're sending me acknowledgement with the same number, that means there's something wrong with this frame. So now, let me get something else. So we're still waiting on number 2. And I sent you an acknowledgement. I said, send me number 2. But if I get into memory, what will I get next? I got 0, 1, 2, and the next one I get number 3. So I look at number 3. There's nothing wrong with it. But there is an issue with it. You know what the issue is? I'm waiting on number 2. There was something wrong with number 2. I discarded it. But in the memory, remember, this was already sent. Those 4 were already sent earlier. They're all sitting in my memory. 0, 1, 2. I got 0, it's good. Send it to my user. 1, good. Send it to my user. Number 2 has an error. Discard and send an acknowledgement to you, to the sender. Now I look and there's another frame. I pick it up. It's number 3. Hey, I'm waiting on number 2. I'm not waiting on number 3. So this out of sequence error. Out of sequence error. So it has an error. It's just that kind of error. What is it? It's out of sequence. What do I do with it? Discard it and send normally an acknowledgement to the receiver, to the sender. But we've already sent the acknowledgement 2. This is exactly like this situation here, where we're using window size 4, and we're at this stage. The sender sent frames 0, 1, 2, and 3, and here they are, 0, 1, 2, and 3, because our window size is 4, and the receiver sent back acknowledgement 2. That means there's something wrong with 2. Or the receiver says to me, send me number 2 again. No, and the moment the sender receives an acknowledgement, it will move the window, push the window to that number. Now it looks and says, okay, I can send 2, 3, 4, and 5. But how do I send frame number 2 again? Let's imagine the frames we are sending are coming from a mobile phone or WhatsApp. You are talking to somebody. For example, your device is taking your sound and sending it to someone else and putting it in packets, breaking it into packets. Of course, translates it into ones and zeros and keep sending them in packets, packet 1, 7. It's all your sound. And then suddenly the receiver says, no, send me back the packet number 2. So you cannot ask your user, say, can you repeat what you said? Can you not? You cannot ask the speaker to repeat what they said. You're a device, you're just a microphone and your data. So for all this, anytime you want to send copies of those packets, you need to keep copies of them. So in fact, the sliding window protocol, every time it gets packets to send, it keeps copies. The sender keeps copies. So in this case, when the sender sends you frames 0, 1, 2, and 3, it actually keeps copy of frame number 0, 1, 2, and 3. So the sender side in the data link layer must have enough memory to store few frames. How many frames? In this case, we agreed on window size 4. That means it must be able to store 4 frames. So guys, the sender cannot agree on window size 5 if it does not have enough memory to store 5 frames. So we always need to know what's the maximum size of our frames, how big each frame is, and what's the window size. Let's say every frame is 1000 bytes, and we have agreed on 4 window size 4. That means you must be able to keep 4 frames. Each one of them is 1000 bytes, and you must have 4K bytes, okay, to hold those frames. It's simple. So that's just a piece of requirement that only the sender needs. The receiver does not need them, because the receiver only takes 1 frame, look at it. It doesn't store it. It doesn't keep it. It's usually stored in the memory of the operating system, but it's in a queue. But at the data link layer, just say, is there something in the queue? Yeah, give me 1 frame. So it looks at it. It's either good, it will send to the user, or bad, it will discard it. It will never keep it. And then pulls the next one in its memory. So the receiver only needs 1 space for 1 frame. There are lots of frames arriving, but they go in the common memory area. But in the data link layer, just say, give me 1 frame. I'm a receiver. Look at it. If it's good, I send it to my user, to one of the applications. If it's bad, I'll discard it. So the receiver needs space for 1 frame. The sender needs a space for how many frames?
4 frames.
4 frames in this communication. If we communicate again, we say, let's use window size 5. Then depends the maximum number of frames that this receiver, as much the sender needs memory enough to store the frames agreed upon in the window size. So if you don't have a lot of memory, you may not be able to go for large window size. Sometimes you can we say, let's go for window size 100. Do you have enough memory to store 100 frames? That's an important point to keep an eye on or to remember. But anyway, so now these frames are sent. How long do you keep those frames? Like, for example, at the start, we sent 4 frames, 0, 1, 2, and 3. And we keep copies of those frames, 0, 1, 2, and 3. How long, when do we delete those copies?
When the next one I receive.
When the next acknowledgement, when the acknowledgement is received. The acknowledgement tells you, the acknowledgement 4, it says everything before 4 is okay. Then everything before 4 here you can delete. So 0, 1, 2, and 3, they're already received. That's it. We don't need to keep them anymore. The receivers told us that they've received up until number 3. How did the receiver tell us? Sent us acknowledgement 4. Acknowledgement 4 means up until 3, I got them. So we can delete them. Now we can send the next few frames, 4, 5, 6, and 7. And this time when we send them, we keep them. We keep copy 4, 5, 6, and 7. And if I ask you to describe it, don't forget to say that the sender keeps copies of those frames. Or if you draw the diagram like this, you draw those things that look like frames with numbers on them. I know that's what you want to say in English, so that's okay. That will do. Okay, so if you draw the diagram and put those boxes here and say this is frame number 4, 5, 6, and 7, I know you mean that the sender will keep copies of those frames. You either write it in English or draw it like that. Right. And how long does the sender keep these copies in its memory? Until it gets this acknowledgement, the next acknowledgement. Now this acknowledgement says acknowledgement 0. What does acknowledgement 0 mean? Did we agree on that? Do you know what acknowledgement 0 mean? Do you know what acknowledgement 0 mean? It could mean, this is what it means. Just these are the messages, put the number instead of n. It means all frames before 0 are okay. That's what it means. What's before 0? What frame comes before 0? See the sequence number there? Before number 7 in this system. So in fact, when you receive acknowledgement 0, it means I'm acknowledging number 7. It does not mean I'm acknowledging number 0. Keep that in mind. Always the one before it is okay. That one is not maybe. That's what for certain, that's what I'm expecting to receive from you. And maybe I had an error. If you sent it to me, hey, there's something wrong with it. Send it again. Whatever it is, that's what I'm waiting for. Anytime you receive an acknowledgement with any number, that means everything before it is okay, and that's the number you must start sending me. Okay, so acknowledgement 0, when the receiver sends it to the sender, that means the sender must start sending that frame 0. And everything before 0, okay. That means number 7 is received, 6, 5, and 4. That means we don't have to keep them anymore. Now we're going to send new frames starting at number 0. Always start at the acknowledgement you receive. So now, acknowledgement 0. So we send 0, 1, 2, and 3, and we must keep a copy. The sender must keep a copy of those frames, 0, 1, 2, and 3. This happens each time. The sender sends a group of frames. It keeps those copies of those frames in its memory. Now, why does it keep it? Because of this. See, this time, where the sender is expecting to receive, if everything was received, 0, 1, 2, 3, are received correctly, what acknowledgement it should send back? If 0, 1, 2, and 3 are perfectly received, what acknowledgement would the receiver send back to the sender? Send acknowledgement 4. That means I've received number 3 and number 2 and number 1. But this time, that's what the sender is hoping for, but he did not get acknowledgement 4, it got acknowledgement 2. What does acknowledgement 2 mean? Everything before 2 is okay. What else? And I'm expecting number 2 from you. And what else? And maybe frame number 2 that you sent me before had an error. Okay, so that's what acknowledgement always means. Maybe we should put maybe here. Possibly. If you sent me this frame, maybe it has an error. If you didn't send it, it's okay. That means that's the one I'm waiting for. Now, this guy is waiting to send the next frame. See, this user at window size 4, it's sent 0, 1, 2, 3, and it's hopping to send number 4. The next one it's waiting to send is number 4. The sender always also knows what's the next one it's sent. So every time it sends one, it puts the pointer to the next one. It sends number 1, says that's the next one I'm sending. When it sends number 2, points at 3. When it sends number 3, it's pointing at 4. It's waiting to send number 4. But guess what? It got acknowledgement 2. That means you have to go back to number 2 and start sending. So it moves the window to number 2 and it has to send the next few frames. But number 2 is already sent before, so we have to send it again. So it goes to number 2. It means acknowledgement 2, it means 0 and 1 are okay. 2 and 3, we've sent them before, let's send them again. So it sends number 2 and sends number 3. Does it stop? No, the window size says 4. You can send up to 4 frames. See, when you get acknowledgement 2, whatever you are sending, 0, 1, 2, 3. Now you get acknowledgement 2, you move the window to 2. The window tells you can send 2, 3, 4, and 5. So you can send 2 more frames, 2, 3, 4, and 5. That's what the acknowledgement means. Go back to number 2. In fact, this part of the protocol is known, this protocol that we're talking about is called the go back in sliding window protocol. So it's a sliding window protocol, but we call it the go back in. That's what this acknowledgement 2 means. Hey, the sender sent me 0, 1, 2, and 3 is waiting to send number 4, just waiting for an acknowledgement. But we say acknowledgement 2, that means go back to number 2 and send again 2, 3, 4, and 5. That's what the word go back means. So this sliding window protocol is known as the go back n as any number. Go back 5, go back 22. That means go back to number 22 and start sending. How many do you send? Whatever the window size says. If it says 4, send 4. If it says 17, send 17, the window size, the agreed window size. But this is the go back in sliding window protocol. So this protocol is known as sliding window protocol, and this version we are looking at is known as the go back in. Because of this effect that while you're working, sometimes the acknowledgement will tell you go back to that number and send it again. Right. So now this guy receives acknowledgement 2, goes back to number 2 and sends 2, 3, 4, and 5. So it sends 2, 3, 4, and 5. Don't forget to mark them here as you have a copy of them. Let's say this time it got number 2, it's okay. That's what it's waiting on. Number 2, it's expecting number 2 and got number 2. Checked it, there's no error. What does it do with it? What do you do with a good frame, the right sequence, errors? What does the receiving card do with it? Send it to the user. Send it to your user. So it goes to, I'll just write you here. Number 3, in fact, I'll put it on top of it. So the user, number 3 is okay. You send it to the user. Now you get number 4. Number 4 has a problem. Not okay. It has an error. What do you send? You send what? Frame number 4, or you send something else? What do you send back? What does the receiver send back? Something called acknowledgement. You send acknowledgement. As you can see, the acknowledgement, it can be good news. You're acknowledging you receive, but sometimes it can mean acknowledge. It's like negative acknowledgement. It's like, hey, I'm acknowledging you, but I have not received 2, 3, 4, and 5. If I did, I'd send you acknowledgement 6. But No, I'm sending acknowledgement 4. That means there was something wrong with number 4. And that's what I'm waiting for is number 4. So what does the sender do here? Acknowledgement 4, it means 2 and 3 are okay. Right? I have to send you 4 and 5, right? Right? 4, 5, 6, and 7. We always assume there is a lot of data to send. So it will send 4, 5, 6, and 7. What if number 7, 4 is okay? What do we do with it? Send to the user. 5 is okay. 6 is okay. And 7 has an error. You send back acknowledgement 7. See how simple it is? What does acknowledgement 7 mean? What does acknowledgement 7 mean? That's what acknowledgement means so far. It means, number 1, read me the first one. What does acknowledgement 7 mean? All frames before number 7 are okay. Okay, that means the sender here will say, okay, before 7, that means 4, 5, and 6 are received. I'm going to delete them off my memory. What else? It also means I expect number 7 from you. So send me back number 7, right? Yeah, so now it will send what numbers will it send? Number 7? Anything else? Okay, thank you. What frame numbers will it send? How many frames will it send? Window size. See, window size is 4. That means it'll always send, as long as there is data, it'll send 4 frames and stops. What frame numbers will it send? 7, 0.
No. 0. Start with 0 first.
No, see, when you get acknowledgement 7, that means there's something wrong with 7. Send me number 7. Start with number 7. So you must send number 7. What comes after 7? 0. What comes after 0?
1.
And 2. And make sure, of course, you put copies here of 7, 0, 1, and 2. Okay, do you understand the way things work here with this sequence number? So, okay, we're going to continue. One more time. Yeah. Okay. Let's go now. Window size 5, modulo 8. This is the sender. This is the receiver. Another example, quick example. Right. This guy will send few frames, right? What frame number? Yeah?
Sorry, I have a question back to the middle side.
Yeah, keep asking.
Yeah, my question is, how do you identify the errors?
Okay, we have this guy when it receives it, it's a called CRC error detection. So can you check this frame for me? It doesn't do it itself. It has a function that's called, we've done it before. Maybe it's parity system. You know the parity error detection? If it's error, for example, even parity, it means every byte must have an even number of ones. It finds one of them that has an odd number. It says, no, there's something wrong with this frame, even though we found one error, but the whole frame is dismissed. So it's one of the error detection algorithms. We looked at maybe 3 or 4. We did the parity system, and you need to know how to use them. And the block parity, CRC, and Hamming code. But this one now is the flow control, the sliding window protocol. Now, window size equals 5, and modulo is 8. What does the window size mean? No. What's the window size mean?
Frame.
Yes. That's the first word. What is it? The maximum. Not the number of frames you can send. I don't know. Did you say maximum? No, you didn't. Maybe. I'm sorry if you did say maximum. Okay, it's right. If you didn't, remember it, please. The window size is what?
Maximum amount of maximum each frame that the user has to send.
Yeah, that the sender can send. Yeah. Okay. So The window size is the maximum number of frames that the sender can send. And what's the modulo? What's modulo 8 or modulo 128? Yeah, it's a sequence of numbers that are recycled. And we use sequence of numbers that are, it's a group of numbers that we use for the packet numbers or datagram numbers or frame numbers. And it's recycled. Every time we reach the end, we go back to 0. We always start from 0. Modulo 8, that means you have 8 numbers from 0 to 7. Modulo 1 to 8 has 127 numbers. Start from 0. Sorry, it has 128 numbers. Start from 0 to 127. And then when it gets to 127, the next number is going to be go back to 0. All right, so now we have modulo 8. That means this is the sequence numbers we are going to be using. 0, 1, all the way to 7, and then 0, 7, and we keep going that way. And the window size is 5, so here's the window size 5. And if we put the window size at the 0 at the start, it shows the sender what frames it can send. It can send frames 0, 1, 2, 3, and 4. So if you're asked to give an example, this is a good example. You said this guy sends 0, 1, 2, 3, and 4. That's 5 frames, right? Don't forget to say, hey, keep copies of those 0, 1, 2, 3, and 4. Let's say they are all sent. Let's say frame number 2 was never received. Now, when we start, this guy has the next frame I expect is number 0. It keeps incrementing it each time it receives a good frame, right? So if the received frame is not what we expect, then we say, sorry, we discard it. That's another error. The error can be a bit error, but it can be, that's the wrong frame number you're sending me. I can't accept that. Remember, you must accept only the frames in the correct sequence. Out of sequence, that's an error. Right, so this guy got number 0. What do we do with number 0? It's perfect. There's nothing wrong with it. Send it to the user. Number 1 is good. What do we do with it? It has no error. Send it to the user. Number 2, we didn't get. We got number 3. Oh, hey, we're waiting on number 2. That's an error. That's an out of sequence error. What do we do in the case of out of sequence error? We send back acknowledgement. What acknowledgement should we send number? 2. That's what we're missing. What does acknowledgement 2 mean? It means number 0 and 1 are okay, the ones before 2, same meaning. We always repeat the same thing. Acknowledgement 2, it means everything before 2 is good, which is true. We got 0 and 1, perfect. We sent them to our user. And we ask in the sender, we say, hey, we're waiting on number 2 from you. That's what we expect to receive from you. And before, we said, maybe this frame has an error. This time, we say, maybe this frame is out of sequence. What kind of error? Hey, it could be out of sequence error. But that's not acknowledgement. I should have made another list of errors. So these are 2 errors so far. Either an error, a bit error in the frame, or a frame out of sequence. And we send acknowledgement 2. Okay, but instead of 2, we're going to get in the frame number 3. Okay, we got number 3. What do we do with number 3? Discard. I put the character D to discard. And then we got number 4. What do we do with number 4? Discard. That's the wrong. We are waiting for number 2. We can't accept anything but number 2. So now the sender, instead of acknowledgement 5, we got acknowledgement 2. What does that mean? It means go to number 2. I know you're going to send me 5 next. No. Go back to number 2. That's what the acknowledgement tells us. Go back to number 2 and start sending. 0 and 1 are okay. We can delete them. And we send, what frame numbers will we send? 2, 3, and 4, right? 2, 3, 4, and 5, right? Yeah. And what else do we do that we should not forget?
We should write the memory.
Yeah, just keep copies of those frames. 2, 3, 4. We already have 3 and 4 and 2, but add to them 5 and 6. And now we have copies of those frames.
Copies in memory?
In memory of the data link layer, it has its own memory.
Sender memory or receiver? Which memory?
No, the sender. The receiver doesn't have to keep nothing. It just needs one space of memory. Bring the packet into it, process it. If it's good, send it to the user. If it's bad, discard it. Hit the next one. So it only needs very little memory, the receiver. The sender must have enough memory. Well, if you are a sender and a receiver, it's more sensitive to the sender. If we say, let's use window size 100, it makes no difference to the receiver. The receiver doesn't need memory. All the packets will go into the queue in the general memory, but in the data link layer, it only takes one at a time. Good, send it to the user, don't even keep it, or discard it. But the sender must have enough space for 100 frames. So window size, for now, it looks like it's more sensitive to the sender. If we want to negotiate, we want to say, what window size shall we use? We use a 100 or 5. The sender might say, hey, I don't have memory for 100. So we have to go use the lesser memory. All right, next one. So we know we can have the kind of errors. Maybe I'll just mention the errors here. We have one error is bit error. Any bit error will make the frame is no good. We already tried there. Number 2 is lost frame. A frame is lost. But gets another one. Yeah, perfect. That's exactly how a lost frame is discovered. It's not discovered by the sender, it's discovered by the receiver. How is it discovered? Okay, I'm waiting for frame number 2, I got number 3. Hey, where's number 2? Then I know number 2 is lost. Okay, so that's as simple as it is. Now, so that's a lost frame. There's another frame. Sometimes it's not lost, but we get out of sequence. We get the error, we send back the error, but we receive another one out of sequence. So I'll just write it here, out of sequence. It's like the lost frame. But sometimes not because it's lost, because the one before it had an error, we discarded it, we get the next 2 or 3 of them, they're all out of sequence, we also discard them. Now, a lost frame is discovered by the receiver. Time is up? Yeah. Right, okay. Let me, just one last thing now before you go. Right, we got number 2. We got them all perfect. 2, 3, 4, and 5, and 6. What do we do with them? Send to user. And we send back acknowledgement. What acknowledgement we send? 7, yeah. It means I'm waiting now number 7. But guess what? This acknowledgement was lost. You don't need to send them again. They're all received. Hold on. Remember, this is like everything happens based on events, event-driven kind of system. When the sender sends those frames, it goes to sleep. When will it wake up again? When an acknowledgement is received. Only when an acknowledgement is received, it doesn't say, wake up, there's something here for you at the door. Let's say you're asleep at home. You're waiting, you're a receiver. You're waiting for some delivery. You go to sleep at home until somebody rings the bell. The operating system rings the bell and says, there's something for you. So you wake up, you go and take it, process it, and you go to sleep again. You don't stay processing, waiting. Is there something coming? Is there something coming? Is there something coming? That's called busy wait. That's not good way of programming. Good way of programming, you do the work and go to sleep and tell the operating system, wake me when this event happens. So those two are waiting on events, something arriving. This guy, if data arrives, it will be awakened, process it all and go to sleep. This guy sends everything, goes to sleep. When the acknowledgement arrives, it will wake up. But if the acknowledgement never arrives, it will never wake up. What will happen? How do we get out of that system? Now, they introduced something else to solve this problem. Every time you send a frame, you start a timer for that frame. What does the timer say? The timer, let's say, you send a frame now. Let's say now it's 6 o'clock, for example. And it takes, for example, 3 minutes for the frame to be delivered. It takes 3 milliseconds or less. But let's say, just for easy numbers, it takes 3 minutes for it to be delivered. It takes the receiver to process it. And then it takes 3 minutes for the acknowledgement to come back. So that's 9 minutes altogether, give or take. When multiplied by 5 or 10, 90, right? Multiply by 10. That's, you set an alarm for 90. So give a chance if this guy got delayed going up, the processor got delayed there, the acknowledgement got delayed coming back. We don't want to be waking up each time. So we set a long alarm. Like you set an alarm in the morning, you want to wake up at 9 o'clock. But always the acknowledgement arrives early. So when the acknowledgement arrives, you turn the alarm off first thing. So it's like when you wake up, you set your alarm at 9, but you wake up at 8. You say, okay, first thing, switch off that alarm. So that's the timer. So every time we send a frame, we start a timer. It will go off after a long time, but it's not very shortly. So this is enough for all these frames to go. Like every frame will have a timer. Timer 0 for frame 1, timer for frame 1, 2, 3, 4. Right. And when we get the acknowledgement, we go and turn all these timers off first thing. And then we say, okay, the acknowledgement is number 2. That means, okay, 0, 1 are okay. Now let's retransmit 2, 3, and 4 and start a new timer for 2, timer for 3, timer for 4, timer for 6. Each one of them has a timer. Now we send this, we wait for the acknowledgement sent, but it's lost. We never got it. So after, say, 100 milliseconds, the first time I go, that means the sender wakes up, what's wrong? You say, oh, your frame number 2 something. This is it's called the retransmission timer. That means if this timer goes, send that frame again. So it takes a copy of this frame and send it out again. By the time it finished sending it, and start a new timer. By the time it finishes this, the other one will go off. They'll go one after the other because they were set one after the other. So it'll send these frames again, the same frames, and it'll start a new timer. It means, hey, so if the acknowledgement is lost, nobody will know about it, and this will be saved by the timers. We'll finish it on next week. Thank you very much, guys. Take care of yourselves and stay safe, please, wherever you go.